you notice basically related rates gets taken off. Okay, so basically I'm taking the unit, pulling off related rates, and we're going to have a quest larger than a quiz, smaller than a test, over this material. Now, the only unfortunate thing with that is there will be no retakes on the quest. So make sure you're really preparing the first time around, which there's not enough time to do it before the end of the quarter, and unfortunately all you seniors, we can't make any changes to second quarter grades. Yeah, because once it gets sent off. Yeah, so it'll be a similar format where we have multiple choice for response, calculator, non-calculator. Yes, the point that was different.
Being on the same scale.
Like how many points it's worth, or yeah. So it'll still be AP curve. It'll be very similar. It's pretty much just I'm taking related rates off the test and bringing that down. So we will do related rates. I love related rates, but it just won't be on this unit.
That was good.
I love that. It's so good. So then we'll learn related rates. And so related rates will come. I'm not sure if I'm just going to do just like a 3-day thing on it, we quiz and be done with it, or if we'll put it on the next unit. But this is what we're going to do before the end of the quarter. Does that make sense? Okay. So let's take a look at 5.1. And it looks like I didn't actually read what the bubblegum face said. Number 7 we'll start off with. And I've spaced this out for more room, so it might look like it's in a different spot on the page than it was for you. Okay, so in number 7 it says that g be a twice differentiable function, where we have some fancy information there. Let h be a function such that h of x is made up of g of x. So it tells us to show that h prime of -1 equals h prime of 9. And then use this result to show why there must be a value c on that interval such that h double prime equals 0. Okay, so they gave us a lot of information. First of all, they said that g is a twice differentiable function. Remember, if it's differentiable, it means that it's continuous. What twice differentiable means is that we can take the derivative twice. The first derivative and the second derivative both exist. So we know then that the original function is continuous as well as its first derivative, because the first derivative itself is differentiable, which means it's continuous. Now, h is made up of g of x. Since h is a composition of a continuous and differentiable function, then we know that h itself is also continuous and differentiable. Okay. Now, they asked us to show that the heights of our endpoints for the derivative are the same. When we're dealing with the derivative, that probably clues us into the mean value theorem or the specific case Rolle's theorem. And Rolle's theorem is when we do have that our endpoint heights are the same. Okay, so that's going to kind of clue us in that we're dealing with Rolle's theorem. Now notice though that we're dealing with the first derivative as our function. And so we're trying to show that its derivative, that's the second derivative, equals 0, which follows from Rolle's. Rolle says that if my endpoint heights are the same, then the derivative will equal 0 somewhere. So if the endpoint heights of the first derivative are the same, then its derivative, which is the second one, equals 0. So that's where we're headed with all this. All right. So we have to first show h prime of -1 equals h prime of 9. So we need h prime. So h prime of x. This is composition of functions. So what am I going to have to use for that? By the composition. The chain. So I have outside stays, or sorry, ignore that part. Outside we take the derivative of inside stays. So my inside stays. And then what do I have to do? Derivative of the inside. So multiply the derivative of the inside. So we have my derivative for h is g prime of g of x times g prime of x. Okay, so now let's go ahead and find these two guys. So I need h prime of -1. So wherever there's x, I'm going to be putting in a -1. So g prime of g of -1 times g prime. And what is g of -1? 9. They gave that to us. Now sometimes they do give you information you don't need on problems, but this type of information you're probably going to be using in some way, shape, or form. Okay, so we have, that's actually g prime of this guy was 9. So 9 times g prime of -1. Okay, we don't know that information, we don't have a function, so we're just going to pause it. And let's go ahead and find h prime of 9. So h prime of 9 is g prime of g of 9. So again, we want to evaluate that. Which is g prime of 9. So again, I'm just putting it in wherever I see the x. And what was g prime, or sorry, g of 9?
-1.
-1. So this is just -1. So I have g prime of -1 times g prime of 9. Are those the same? Yeah. Now it doesn't look exactly the same, so I want to rewrite it so they perfectly match. So I'm just going to go ahead and rewrite this as g prime of 9 times g prime of 8. What property again allows you to do that? Muted it. Okay. So therefore, h prime of -1 equals h prime of 9. All right, so we've satisfied that. Questions with that, please? So then it says, use this result to show why there must be a value on the interval where its derivative is 0. All right, so again, we said this hinted toward roles, and roles is from mean value theorem, and mean value theorem's requirement is that it's continuous and differentiable. So the fact that it's asking about h prime and its derivative is h double prime means that the original function we're working with in dealing with roles is h prime. So h prime is my function I'm working with. So I need to make sure h prime is continuous and differentiable. And again, since g is twice differentiable, that means that g prime is going to be also differentiable. And we can see h prime was made up of g and g prime. Those are both continuous and differentiable, so we know h prime is continuous and differentiable. So we need to state that. So since g is twice differentiable, then h prime is continuous and differentiable. Differentiable. Okay, which means that mean value theorem applies. Okay, now we know that we can apply rules specifically because of those endpoints. And since our endpoint, so since h prime of -1 equals h prime of 9, then by rules, then we just pretty much write out what rules theorem says. There exists a value c. Right, they called it C? Yep, okay. The value C such that C falls within the interval from -1 to 9. And the derivative at C, it's the derivative of h prime, so h double prime of C, must equal 0. Because again, our endpoint heights are the same, which means if I did my average rate of change, I would get an average rate of change of 0. And Rolls or MBT says my instantaneous must equal the average somewhere on the interval. That's answer. Questions with that? You'll notice that, so what we did on this day, so mean value theorem and intermediate value theorem, there's quite a bit of writing for your answer, but it's really just presenting what the theorem says. Okay, let's just get a 12 minutes. Okay, if C is the number that satisfies the conclusion of the mean value theorem for f of x equal yada yada on the interval 0 to 2, then c equals what? Okay, so what they're asking here is for us to find the actual value that satisfies mean value. And again, mean value theorem says if it's continuous and differentiable, then somewhere on the interval we have that our instantaneous rate of change must equal our average rate of change. So we're trying to find where on the interval, what is the c value for which that occurs. Alright, so they tell us if c is the number that satisfies the conclusion mean value, then find c. Alright, so first of all, is f of x continuous? Yeah. Is it differentiable? Yeah. It's polynomials, continuous and differentiable. So f of x is continuous. I'm going to abbreviate. And differentiable. Remember for response. Oh wait, there's multiple choice. I didn't have to write that down. I just had to check that it was so. Okay. So I need to go ahead and find what is my instantaneous and what is my average and set them equal to each other. Yeah.
How do you know that f of x is differentiable? Just because it's a normal polynomial?
Yeah. Yeah.
Right, and then it would only be non-differentiable if it was to a value or
something with that corner or cusp or piecewise
how do you figure that out?
Absolute value. It's probably going to be some type of extreme equation. So polynomials are pretty much good to go. Beyond that, you're going to have to take up the graph. Also, we only need to make sure that it's continuous differentiable on that interval. So, like, just keep in mind, like, if it was a piecewise and there was a jump somewhere, but we weren't looking at where that jump was, and only look at the interval that they're questioning. Polynomials. Alright, so we need to find our instantaneous rate of change. So remember, our big idea is we want IROC to equal AROC. So my instantaneous rate of change is my derivative. So I'm going to go ahead and do my derivative here. F prime of x equals 3x squared minus 4x. So that's my instantaneous. I'm going to go and write that out. Now we want that to equal our average rate of change. And so my AROC is going to be on this interval, so we want f of 2 minus f of 0 over 2 minus 0. Alright, so we need to find those actual values. So f of 2 would be 8 minus 8. 0. Is that right? And then f of 0. 0. Yeah?
Yeah.
Okay. So my average rate of change would be 0 minus 0 over 2, which is 0. Okay, so my average rate of change is 0. So we need to solve this guy here. We're trying to find when does instantaneous equal average. Questions so far? So now it's just factor. X, so we have 3x minus 4 equals 0. So we have x equals 0, x equals 4 thirds. But you say, wait a second, none of these have two answer choices. Well, because with mean value theorem, hold your horses, there's a small piece of technicality that is kind of important. And mean value theorem says that there exists a C on the open interval that will satisfy that. Let me pull it up so you can see it. Alright. So mean value theorem says if it's continuous on the closed, differentiable on the open, then there exists a C such that C is contained within my interval. But notice C cannot be either of those x value endpoints. C has to be inside of there, cannot be one of the x value endpoints. So that is why we are then able to say, 0 is part of my interval there, so I don't take the 0, I take only the 4 thirds. Okay. So again, we choose 4 thirds because we cannot have my C value that satisfies it be on these endpoints. Questions with that? goes 16. Oh, maybe we should have done 6 while we were there. 7. Alright, so the function is continuous on the closed interval, 0 to 2, and has values that are given in the table above. The equation f of x equals 1/2 must have at least 2 solutions in the interval 0 to 2 if k equals what? Alright, so they gave us that the function is continuous. Did they give us anything about it being differentiable? No. So remember that IVT, MVT rules. IVT only requires continuity, and IVT is looking to see, do we hit that y value somewhere within the interval? So if we look, we only have continuous, and they're wanting to know how often is my function actually hitting 1/2. Okay, so we're trying to find out how many times, or the equation must have at least 2 solutions in the interval if k is 1. So we need to figure out what is this value to guarantee that my function hits 1/2 2 times. Okay, so it's continuous, which means there's no jumping around. So we need to figure out what can k be, that when it goes from 1 to k and k back down to 2, it has to hit 1/2 twice. So essentially, we need to have that it hits 1/2 somewhere between each of these. Okay, so you can kind of think of the graph, or you can think of just kind of guessing and checking here. So if I take a look at my graph, at 0 we have 1. And at k, where that maybe is going to be 1, so 1 is somewhere here. And, or sorry, at 1, it's k, so k has to be somewhere in there. And then at 2, so my function is continuous, and so it's going to do something in between here. We're not sure what it's going to do, but we want it to hit 1/2 twice. And so 1/2 is going to be down here, right? So k needs to be a value in which that it has to cross to get to 1/2, coming down to it and going back up to it. Does that make sense there, Amelia?
What's the difference between solutions as in crossing the x-axis and solutions as in f of x equals 1/2?
Yeah. So solutions crossing the x-axis means that our function equals 0. Here it's asking what are solutions that makes the function equal to 1/2. So we're wanting to know what does k need to be where our function hits 1/2 twice. Over here, what does x need to be that our function hits 0? Okay, so again, pretty much need to go 1 down to whatever k is going to hit 1/2, and going from there back up to 2 is going to hit 1/2. So in order to hit 1/2, we definitely have to be less than 1/2. Right? Otherwise, it's never going to hit it. So that helps us eliminate this. Do we agree? Ooh, that's pretty nice. Now we got a 50-50 shot. All right. So if we were 1/2, if this was 1/2, is my function going to hit 1/2 twice? Guaranteed? No, that's only a guarantee of 1 time, right? But if my function is indeed 0, then what we have happening is that this has to cross to come down to 0 and go back up. It might do something more, it might hit it more than that, but it has to have at least those 2 solutions because it has to cross 1/2 to get from 1 to 0, and then from 0 to 2. So that's how we get our answers. Questions with that? Okay. Let's go back to 6. Oh, yes, 6. I'm glad. Okay, so the key for 6 was wrong because the key treated it as if it said h of t is 3. But it doesn't say that. It says h prime of t, which completely changes what we're doing here. Okay. So the functions f and g are continuous and differentiable for all real numbers. And the function h is given by yada, yada, yada. Table below gives us the value of the functions. Explain why there must be a value on the interval such that our derivative equals 3. All right. This, we're dealing with the derivative. It's probably hinting towards us mean value theorem or rules. But probably mean value theorem, we don't have anything about our endpoint values being the same. So probably leaning towards mean value theorem. And again, the big idea of mean value theorem is that IROC equals AROC. So what we can say from here is, well, it's saying why must there be a value where the derivative equals 3? So there must be a value that my average rate of change is 3. If my instantaneous rate of change is 3 and we can't apply mean value, then our average rate of change must be 3. So first let's check, can we even apply mean value here? Alright, well they tell us f and g are continuous and differentiable. Once again, since h of x is made up of f and g, and those are continuous and differentiable, h of x must be continuous and differentiable. Is this part of my function, negative x, is that a continuous and differentiable function? Yeah, so every piece of this is continuous and differentiable, so thus we have h of x is continuous and differentiable. So let's first go ahead and state that. And it says explain, which means we need words. Alright, I'm going to start over here. Do I have room to do it over there? More or less. Okay. Since f and g are continuous, I'm going to abbreviate, don't do that, and differentiable, then h is continuous and differentiable. Okay, so that allows us to know we can apply mean value theorem. Mean value theorem says, hey, if that's true, it must happen that my derivative equals the average rate of change at some point in time. So let's just check to see what our average rate of change is. So my AROC would be h of 4 minus h of 1 over 4 minus 1. Now we have to use a chart and fill in the values, but when we do indeed do that, we get h of 4 is 4. H of 1 is negative 5, which yields 9 over 3, which is 3. So we have our AROC is indeed 3. Okay, so if my average rate of change is 3, by mean value theorem, it has to happen that my instantaneous rate of change for the derivative must also be 3. So now we just need to state that. Alright, so we stated it's continuous differentiable, so by the mean value theorem, there exists a value t, since that's what they use, such that t is on the interval 1 to 4, and h prime of t equals 3. And we need to go ahead and specify that our average rate of change is 3, so we'll just go and say since h of 4 minus h of 1 over 4 minus 1 equals 3. So we're saying, hey, we meet the conditions for mean value theorem, so there must be a time where my derivative equals 3, because my average rate of change is 3, my derivative must equal 3. So I apologize if the Q was wrong on that. If it had said h of t, the Q would be correct, but it's not. Alright, questions with that one? Okay. And the remaining 30 seconds that we have, let me see what the course says. Alright, so before we had twice differentiable, which again means you can take the derivative twice. And G is made up of a composition of F, so we can apply the mean value theorem because it is continuous and differentiable from the fact that it's made of F. But it says to apply it to G prime. So when we go to do IROC equals AROC, my instantaneous rate of change of G prime would be G double prime of X, and my average rate of change would be using G prime. So G prime of B minus G prime of A over B minus A. So you would need to first find your derivative, which would be f prime of f of x times f prime of x, and then you'd have to find g prime of b, g prime of a, etc. Okay, see you guys on Tuesday. Like you're saying, maybe if we get snow. Yeah.